Okay, kids, this is going to be hopefully a quick explanation of problem set A4. And the first thing we want to do is we want to sketch a slope field. So remember, at each of these points, I just want to draw a tangent line that represents the slope at that point. So if I think of the point 0, 0, plug it in, I will get a tangent line of 0. If I think a slope of the point 1, 0, so that'd be a -2 times a -1, so that'd be a +2. So my slope is going to be a tangent line like this. And what you want to do is you want to go and fill in each of these tangents, figuring out the slopes and drawing them in. So I'm going to leave the figuring out to you, but a final answer is going to look something like this. In part B, we want to show that any point with an initial condition along the y-axis where y is greater than 1 creates a relative maximum. Now this right here means that x equals 0. So if I'm along the y-axis, x is going to equal 0, and when I plug this in to my derivative, I'll get dy dx is going to equal 0. So when I'm along the y-axis, I get critical numbers. Now, if I want to deal with the idea of a relative maximum, I don't have an original function to work with, so what I want to do is use the second derivative test. So what I'm going to do is I have dy dx equals a -2x times a y minus 1. I want to take the second derivative. And that second derivative, when I work out, I'm going to have to use the product rule. So remember, first derivative of the second plus second derivative of the first. And when I go through and take that derivative, d squared y over dx squared is going to be first derivative of the second plus second times derivative of the first is going to give me this. Now remember that dy dx was a -2x times a y minus 1. And if I have everything else here, this whole second derivative is going to simplify into 4x squared minus 2 times a y minus 1. Now, when y is greater than 1 and x equals 0, I plug those in. So d squared y dx squared, when I plug in 0 for x, and I plug in something greater than 1, let's just plug in a 2, I know that I am going to get a -2 times a 1, so I get a second derivative, which is a negative value. Since the second derivative is less than 0, concave down tells me I get a relative max by the second derivative test. Now in part C, what I want to do is I want to find the particular solution y equals f of x. I am given the derivative, so what I need to do is I need to separate and integrate. So this is going to separate into 1 over y minus 1 dy and a -2x dx. And what I want to do is I want to integrate both sides. Here, I'm going to let u equal y minus 1, du equals dy. So this integral is going to turn into 1 over u du, which is ln, absolute value of u. So it's the ln of y minus 1. This integral is just going to be minus x squared plus c. So what I want to do now is I want to take this initial value, f of 0, plug it in, and when I plug that in, that is going to give me c equals 0. So I get ln of 0 minus 1 equals a negative times a 0 squared plus c. So I get ln of 1 equals c, so I get 0 equals c. So I know that my c value is 0. So what that leaves me with is natural log absolute value of y minus 1 equals a negative x squared. Now the idea is to solve this for y, because I want to find the particular solution y equals f of x. So if I e both sides, I get absolute value of y minus 1 is going to equal e to the negative x squared. Now this right here is the tricky one. I just can't drop the absolute value. I got to remember that absolute value can be written as y minus 1 when y is greater than 1 in this case, and a negative y minus 1 or negative times the quantity y minus 1 when y is less than 1. Since my y value is 0, I'm going to replace this absolute value with this right here. So it all turns into negative times a y minus 1 equals e to the negative x squared. So that's y minus 1 equals a negative e to the negative x squared. So y is going to equal 1 minus e to the negative x squared. In part D, it wants to use my solution in part C, which is y equals 1 minus e to the negative x squared, and I want to evaluate this limit. Well, remember, direct substitution, I'm going to plug 0 into here and then 0 into here. So I get this. I get 1 minus e to the negative x squared on top and the tangent of x squared on the bottom. When I direct substitute 0 in, I am going to get 0 over 0, which is indeterminate. I am going to get 0 over 0, which is indeterminate. So what I need to do is L'Hopital's rule. Now that means I take the derivative of the top, take the derivative of the bottom, and direct substitute again. So the derivative of the top is going to be 0 minus e to the negative x squared times a negative 2x. The derivative of the bottom is going to be secant squared of x squared times a 2x. And this is what I want to take the limit of. Now this does simplify into a 2x e to the negative x squared all over a 2x times secant squared of x squared. 2x's cancel out. Plug in 0, I get e to the 0. Down here, I get secant squared of 0. E to the 0 is going to give me 1. Secant squared of 0, that is also going to give me 1. So my final answer is going to give me 1.